Now we are going to discuss the properties of equilibrium constant. For example, if we have a reaction, say N2 plus 3H2 gives you 2NH3, and you write equilibrium constant for that, you take it as Kc, and we reverse the reaction. You have another reaction which is exactly opposite of the first reaction. In this, N2 plus H2 gives you ammonia, and in other reaction, what happens? Ammonia decomposes to give hydrogen and nitrogen. So, if equilibrium constant for the first reaction was Kc, equilibrium constant for the first reaction was Kc, and for the reverse reaction, equilibrium constant is Kc dash. And what would be the relation in them? Kc dash will be equal to reciprocal of Kc. That is, Kc dash equals to 1 upon Kc. So just remember this, very simple. If I say the value of Kc was 2, so Kc dash will be 1 by 2. That's it. So it is very simple. If we reverse the reaction, the new reaction has equilibrium constant reciprocal of the previous reaction. Alright. And another property is, if you multiply a given reaction for a original reaction, if equilibrium constant is Kc, and if you multiply that equation, let's say with n or 1 by n, then equilibrium constant of the new reaction Kc dash equals to Kc raised to the power n or 1 by n. For example, we have taken over here, you have reaction 2NO2 gives N2 plus O2. In another reaction, we have divided the previous equation by 2. So, Kc dash equals to Kc to the power 1 by 2. That is what I was saying. If you multiply by n or divide by n, then you take the complete value. For example, you have A gives you B, and I multiply. If for this reaction I write Kc, so Kc dash for this reaction will be Kc to the power n. And if I divide, let's say 1 by n A gives 1 by n B. So what I have done? I have multiplied by 1 by n. You multiply by n or multiply by 1 by n. So Kc double dash for this reaction is equals to Kc of original reaction raised to the power 1 by n. Here what we have done is, we have divided by, we have multiplied by 1 by 2. You can say divided by 2, or I say multiply by 1 by 2. So Kc dash becomes, Kc dash here becomes Kc raised to the power half, that is a square root of Kc. Alright. Next, we have relation between Kp and Kc. What do you think? What is Kp and what is Kc? So what is Kp and what is Kc? I'll just make it clear for you. If you have, let's say A gives you B, this reaction, I write equilibrium constant Kc. What I am going to write? Concentration of B upon concentration of A, right? So this is Kc. If I have to write Kp, what will be there? Assume these are gases. Assume these are gases. So you have taken concentration values, then we say equilibrium constant as Kc. When we put partial pressure values, then we say Kp. Then what you do is, use partial pressure of B upon partial pressure of A. So that's it. There is not much difference. Instead of concentration, you have to take partial pressure. This is applicable only for gases. So the relation between Kc and Kp comes out to be Kc equals to Kp. I'll take it to another page. Kp equals to Kc RT to the power delta Ng. And what is this delta Ng? Delta Ng equals to number of gases on the reactant side, number of gases on the product side, minus number of gases on the reactant side, right? For example, if I take, if I take this reaction N2 plus 3H2 gives you 2 ammonia molecules, then what will be the relation for Kp and Kc? Kp equals to Kc RT delta Ng. What is delta Ng? How many moles are there? 2. And how many moles are there? 3 plus 1. So there are 4 moles here and you have 2 moles here. So delta Ng is 2 minus 4, that comes out to be minus 2. So Kp Kc put minus 2. So the relation is this: Kp equals to Kc R2 to the power minus 2, that is the value of delta Ng. So we have got the relation between Kp and Kc. Now I'll give you a trick. If this value is less than 1, what will be the relation? It will be, it is negative, let's say it is negative. So what do you think? Kp is greater or Kc is greater? Kp means Kp will be equals to Kc divided by RT to the power 2. That means Kp is lesser than Kc if this power is negative. If this power is positive, then Kp is greater than Kc. If this power is 0, then Kp equals to Kc. So depending on what delta Ng is, the relation could be derived from here. That is what we have discussed with examples over here, that taking this example says that our reaction is multi-step. One step, if the equilibrium constant is K1, for another step equilibrium constant is K2, then overall equilibrium constant will be K equilibrium equals to K1 into K2. If there is a reaction which happens in 3 steps, then equilibrium constant overall reaction will be K1 into K2 into K3. So that's it.